All right, everybody. Glazer Mister here. Good to see you. And we're back on Tuesday, day 2 of first week of distance learning. And so the videos today, first of all, this is all on your Google Classroom, okay? And the videos today, what we're going to try today is there is a Google document that I shared with you on there with this video and a couple other videos and links to sites about a Foucault pendulum. So head while you're there because you saw this video, but look at the other links, okay? Then your end goal for today is going to be to fill out that Google Doc with a couple questions there and submit it, okay? This is, you know how to do this. I've never done this part before, so this is really so I can see, okay, this is what it looks like when all the kids submit Google documents and what they look like on my end. So that's what we're trying to get to today, okay? So, Foucault pendulum. What is a Foucault pendulum? Can I see this, please? I've got an assistant. No, not yet. No, not yet. Hold on. Okay. We got a beautiful pendulum here, okay? Anything can be a pendulum, right? Remember, pendulum is a mass on the end of a string, really, okay? So, a Foucault pendulum, invented by Léon Foucault, a Frenchman from Paris in 1851. And the original Foucault pendulum was 28 kilograms, a giant metal sphere, 28 kilograms. There's pictures on the links. 67 meters long, so the cable was almost 200 feet long, and it was hanging in the Pantheon in Paris, which is a giant domed building in Paris where he could hang this pendulum from the ceiling and really let it swing back and forth. Okay. There's one of these at the Cal Academy of Sciences, so if you've ever been there, you may have seen that in Golden Gate Park, and they have them at science museums all around the world. What does a Foucault pendulum do? Foucault designed this because it is really the only way we have to prove that the Earth is rotating without looking outside of us, right? So with a Foucault pendulum, you could be in a totally enclosed room or box and not be able, obviously, if you can see the sun, you can see the stars, you can prove that, oh, we actually are rotating and this is why. But if you're in a totally enclosed box, right, and you can't see out of this, the only way to prove to somebody that the Earth is rotating is with a Foucault pendulum, okay? And so how do you do this? If you've seen this in the Science Museum, great. If not, you can look at the video. I took a video of one of our trips to Paris. We went to the Arts et Métiers Museum in Paris, which is kind of like the nerdy science museum in Paris. And we watched I have a video of the pendulum. There's a docent giving an explanation in French of what's happening there. So those of you that are francophones will be able to understand that part. If not, just mute it and just watch. And what happens is, over time, right, this pendulum swinging back and forth, and usually they have, can you see this? Oh, it's blue on blue. Usually they have these little little dowels or something balanced there, right? So over time, what happens is the Foucault pendulum appears to be moving, right, and knocks over these little pendulums, right? And then if you stay there long enough and wait again, it'll knock over the next one and the next one and the next one, right? And it moves in a circle. It appears to move in a circle. Okay, so what's really going on? In Paris, the time it takes for a Foucault pendulum to go all the way around a complete rotation is almost 32 hours, 31 hours and 50 minutes, okay? And this is, what?
Not inside the North Pole.
Oh, not inside the North Pole. The assistant needs to be quiet back there, but he's about to come in here, okay? And, well, come on in, Dev. We're going to show you. This is my little guy. He's our physics assistant for today. What's your name?
Devin.
Dad's Devin. Okay, he's going to help us with this. So, easiest way, I think, to explain what's happening with a Foucault pendulum is actually to look at the two extremes, okay? The North Pole or the South Pole and the equator. I'm going to try to scoot this back a little bit. I think that'll work. Well, it's a little crazy, okay? And literally just somebody was giving this away on the street a couple days ago, disinfected it, brought it in the house, always wanted one of these. Okay, so here we go. So if we line this up so that the pendulum is going to swing directly over the North Pole. Ooh, should I do this? Okay. And, excuse me, we're going to spin the Earth like this. Okay, Devin, swing the pendulum. Okay. Now, how long does it take for the Earth to make one complete revolution around? 24 hours. Okay. So if you had little tiny dowels set up on the North Pole, that's perfect, and that pendulum swung back and forth, right? You would knock all the little dowels over in a period of 24 hours. Okay. Then they'd all get knocked over. All right. So on the North Pole, that's the easiest, right? Because on the North Pole, it's going to be exactly the time period of 24 hours, because that's how long it takes to move around there. Okay. Now, let's look at the equator. That part makes sense. Okay. Equator is a little different. So now, spin your, yeah, there you go. Okay. Now the equator, there you go. The equator's going like this. Okay. It's moving like this. So what you notice is the pendulum. If you're on the equator and you're looking at a Foucault pendulum and the Earth is spinning in that direction, right? The Foucault pendulum appears to not rotate at all. Okay? It just goes back and forth in a straight line. Okay? So, what happens as you move down in latitude from the North Pole to the equator? Okay? Well, in Paris it takes 31 hours, right? If you move closer to the equator, it's going to take longer, right? If you move closer to the North Pole, it's going to take closer to 24 hours. But if you start moving a little bit south from the North Pole, then all of a sudden it's going to take longer than 24 hours for that thing to make a rotation, okay? There is an equation that you can use using a little bit of trigonometry, and if you know the latitude of the place, to find out the time of the period that it would take, the time to make a full rotation. And you'll be working on some of that in your Google Docs. So again, if you want to see one of these that looks a little more professional than this, check it out in the Google Classroom and make sure you fill in that document. And I think that's it. Do you have anything to add? It's good. All right. We'll see you later.
Bye-bye.